Okay, yeah, so welcome everyone. I hope you had nice holidays and a good start in the new year. Yeah, what we are going to do today is starting with the data curation. So every one of you got a publication assigned. These are listed here in this ramipril studies. And now the main task is to get the data out of this publication, so that we can run simulations and use the data for the model building and for the model validation. Okay, so hopefully you had a look at your publication. And yeah, today I will basically assign myself also an example publication. Today I will run through the steps with this example publication, and then you should basically through the week try to do the same with your publication. And if you have issues, of course, let us know what's going on, because now this will be a bit more complicated, because of course we have to start now really creating some standardized files and also creating some scripts to process the data. Okay, so let's get started. I will just show what what you normally do if you have such a publication. So I selected this Witte 1984. This is a not too complicated study. It measures a bit of pharmacokinetics and pharmacodynamics of the ramipril. This is the Hui 498 in healthy subjects. And basically they used 10 healthy normotensive male subjects. And then they applied 10 milligrams of ramipril and measured the serum concentration of the metabolite. And the metabolite here is the ramiprilat, the active metabolite. In addition, they also had an assay for the ACE activity and reported the time dependency of that, and had a table of pharmacokinetic parameters such as peak concentration, time to peak, half-life, and urinary recovery, and so on, or area under the curve. Okay, so this basically, your publication should look a bit similar, or you should recognize some of these objects in your publication. And now the big question is how we start with that. Okay, the first thing is that you basically go to the repository and look at your data. Basically, go in the data subfolder in the studies ramipril, and you basically will create files in the folder which belongs to your study. So I will basically create something in this Witte 1984 subfolder. So the first things I did is basically I created screenshots of the figures. This is pretty important because we need this at different points. So this is pretty simple. You just basically make this figure as large as possible so that you get a high quality screenshot. You take a screenshot of the figure you're interested in, and only the best thing is then using some graphics program, and then just crop the whole thing to the content. So in these old papers, this often is not working, but in newer papers, you really get nice content. Otherwise, really try to be as close as possible to the content of the figure. And then you would just save this as in the subfolder where you have your study. So we'll go here to the data, studies, ramipril, okay, and I'm working with Witte. And I would save this as, okay, this is figure number 2. So I would make a screenshot of the figure number 2. Okay, and this is basically this is that, and you would do this for the figures and for the tables which are in your publication. This is the first step. This in the end, you have a number of screenshots. In my case, I have now here the figure 2, the figure 3 I already prepared before, the figure 4, and this table. And this is the first step to get the subset of data out. And this is later on really important for the often for the validation and figuring out where did something go wrong. There's most of the time that units are strange, units are wrong, that you typed some numbers wrong, and so on. So it's often like as soon as you start the actual modeling, you will figure out things are not right, and you have to go back to the data and basically see where did something go wrong. And for that, these screenshots are really helpful. Okay, this is basically the first file you generate. Then we create a second file, which is called study JSON. Okay, I will show like first the high level things, and later on I will go more into details. Yeah, but if you have questions, just ask. But okay, at the beginning this will look all a bit much, but in the end you will have something like this content for your study. You will have the screenshots, you will have the PDF, you will create a study JSON file. Where you then create some information, and this is basically what you have to fill out here. It's not too much. You have to fill out this upper part. Basically, you don't have to do much. You have to write the name of the study here. Basically, everywhere where you see, okay, that's already wrong. Where you see Witte 1984. You should write the ID of your study, and the ID of your study is the folder name where the study is in, and the name of the PDF. Otherwise, you would not change much. You have to get the PubMed ID of your reference. There are different ways to do that. Often the easiest way is just going to the Zotero, and if you go basically on your reference here, you have a here in the info, you have here the PubMed field on the right. So you can just copy that. But of course, you could also go to PubMed and look for your study again. So we will just add here your PubMed ID. Like I said, the alternative thing is that you just go to PubMed, and you know the name of your basically the name of your study and the title. Here you would look for something for pharmacokinetics, Roy and Witte 1984. And then you should also find this on PubMed. Or yeah, and you would get the ID from here. You can see this is the same ID, and this is what you write here in the study JSON file. In this, there are a few additional things which are basically important for the mapping of things. And we have to curate different things now from these publications. We have to the interventions, basically what was done in the study, basically what drug was given. Most of the time this will be ramipril or ramiprilat, either intravenous or orally, and perhaps like a single dose or multiple dosing. So we have to encode this somewhere. And this is basically what this file is doing, is just saying, okay, we're mapping this information to the information in a spreadsheet. So if this mapping is done once, you basically don't have to do much. You can just copy this file and just update up here your ID of your study, and you look up your PubMed ID, and then you should be pretty good. And otherwise, the rest we will fill in stepwise. Yeah, we will just fill in this stepwise. So I will just remove all information for now. And then we would have like this pretty empty study ID where we just have something curators. This is the XResearch group. We did this. In this case, I'm normally like checking also the studies, so my name is also written here. Okay, So this would be this very basic study JSON. And then we basically need an Excel file. The naming of these files is important, so you should name all these files always your study identifier, and then with the PDF. The study JSON should just be named study JSON, and the figures are basically just the name and the short ID of the figure or the table you have. Okay, in the spreadsheet, you have different information, and this information is basically encoded in different tabs. And there's I would say a few main tabs. The first tab is for groups, and you have a tab for the interventions, and then you have additional tabs for the actual data. So in this case, I added a tab for this figure 2 because we want to curate the data from this figure 2. Basically, for every figure or for every table, you would create which you want the data out. You would create an additional tab and create the data from this table or figure in this additional tab. There could also be data in the publication itself, in the text. Then you would just create an additional like a tab and call it, I don't know, text or pharmacokinetics or something. This just has to be a unique tab name, and somehow it has to be clear where the data is coming from. Okay, so far so good. The main idea is to fill all this stuff out so that we can upload all this information to the pharmacokinetics database. We have this the pharmacokinetic database. It's available under PKDB, and then we have like around 600, 700 studies already in for different pharmacokinetic information. So there's a lot of data already curated in this format. Yeah, but in our case, we basically will do the same, but we not directly uploading this to this production database, but I set up basically a separate database only for the research group, which is just called XResearch2 and pkdb.com. So this way you can see this is basically the same front end and layout. The only difference is that there's no data in here because we haven't created any data, and so there's nothing in here. But this makes it easier for us because we basically no matter what you do, you're not breaking the production database. And also we have like basically everything which is in this database here is like now data which is for our ramipril model. And this makes it also easier to work with this database because it's not so big and so on and so on. Okay, so this is basically the database where we want to upload the data. And for that, we basically have to run a script to upload this this folder with the information to the database. Okay, so far so good. Now I just have to hope that everything worked so far. Okay, this looks all good. Okay. Okay. Now I close everything here. Okay, what I did now, basically I opened PyCharm and I opened our XResearch project. You can see that it's basically also like the studies and data in and so on. And now what I need is a Python environment where we have the scripts which allow to upload the data to the database and to validate the data. And for that, we have to install a package which provides the scripts, and this is just called pkdb data. Basically, when we started the modeling, I demonstrated a bit how to set up this environment. Okay, but I will document this a bit more. So I'll make here a subset like installation. Okay. So I will show the high level thing, what you basically have to do. And this is creating a virtual environment, which we have here already, this XResearch. And then you have to install the dependencies. That's basically installing the these two dependencies, the SPM which we use to create the model, and now we also have this PKDB data in here, which is used for uploading the data. You could also just install the via pip the PKDB data package. So if you have like a Python installation or a Conda installation and so on, so the main thing you have to do is basically have an environment where you have this PKDB data package installed. And what you have then, you get basically scripts to upload the data. And the scripts are named basically upload, so basically upload studies and upload study. And so you would use upload study script and just use a S parameter and point it to the folder where the data is in. So in our case, we want to try to upload the Witte. So this is in the data ramipril Witte 1984. And we would just try that. And most likely this will fail because of course there is something wrong. But the good part is that the script already ran. So basically you see like this is a script, it's trying to upload something, but it basically says there's certain things wrong with our file, and this is basically what is written here. In our case, okay, we basically need a tab prefix for our groups or interventions. So basically every spreadsheet has to start with a tab or a fig name. So okay, this I did wrong. So there's often like if it's not working, you will get this feedback what is wrong. So in this way, yeah, this is okay, and I have to basically while I'm doing that, I also have to write down issues which I find. It's always good if we basically what we want spread allowing groups or interventions and also individuals. And spreadsheets. And this is update validation rule. Okay, and this has to be basically updated in the back end, but that's not what I'm doing now. I'm basically just writing down what the issue is. And similar, you would do if something is totally unclear or not working, you would just open an issue in our XResearch group repository. So I have to look for the right tags. It's related to code. So I would submit this issue. So submitting issues is pretty easy. And so you would, if things are broken or you don't know what's going on, you would write in the Slack, but you would also, if it's something is broken, basically open issues here. We will also have issues for our studies. So one thing which you should do is definitely open a new issue for your study. Okay. So and this works like this, that you go here to the issues in the XResearch, open a new issue, and then name it, basically create, and then this is ramipril, what we're creating, and then the study name. In addition, you would assign yourself to that. So so that we can track who is doing that. And normally it's also a good idea to track a bit, okay, what should be done in the study. So you should normally track which figures and tables we should do. So here it was basically figure 2, figure 3, table 1. So okay, I would and figure 4 also. Okay, so I would track this and just open here. We want to do figure 2, we want to do figure 3, figure 4, and table 1. Okay. In addition, okay, I will add a few labels here so that we can better classify our issues. So one label is definitely data, and one label will be ramipril. And then you would tag your issues with the respective labels. You just select labels. Okay, this is an issue which is related to data, and this is an issue which is related to ramipril. And then it's pretty clear this is handling ramipril data. Okay, and this makes it much easier to okay, first see, okay, what are the issues and so on. And so mainly if you have problems with your own study, you would basically write here a comment and say, okay, I don't know how to do that and that. Or if I find problems with the study, I would write you here, okay, this and this is basically not working or should be updated. And that's that we have basically one issue where all the basically where the details and the things which happen during the data curation are tracked. Okay, and then we also have an overview what is happening here. Okay, this was would be opening the issue. Okay, but still not, our study is not uploading, and this was basically because okay, there were something wrong with the table names. Okay, so I will just rename the sheet. Okay, this is basically a table with the groups, and this is basically a table with the interventions. I just rename the sheet. It's called tab interventions. Okay, and then that's it. Basically, what is uploaded, or what the script tries to upload, is what is defined here in this mappings. So for right now, it's basically doing a basic validity checks on this Excel spreadsheet. If things are if things make somehow sense at all. So we will I save the file. I will retry the upload. And we see there's still an error, and there's basically the study column must contain the study ID. First column in the sheet tab interventions contains this here. And that basically means we have study. We have always a study column in our in every of these tabs, and this allows just to basically here the study column, also in the interventions and so on. And this allows to map his spreadsheets in the end to the actual study. Okay, here was just data left, and here is Nishisato. Okay, but this is wrong. We didn't encode any intervention so far, so I will just save that, and I will just also remove all the information we have in here for now, so that we basically have empty spreadsheets with a few table headers, and we will try to fill this out. The only thing I did is I copied in the screenshot here of this image. Okay, let's try again if we can upload this. Make it a bit bigger. Upload study. Okay. Okay, that's not good. So it complains basically that this user is not existing. Oh man, that's not nice, because this user should basically exist. I'm not sure if probably I didn't Not sure if I did everything correct before, but for now I will just remove the user and okay, I will add the users. Okay, this is another issue. This is basically something I would also open here. And this is basically for myself to track what is going on. New issues. I have to create new labels also. So I would just basically yeah, this is basically a bug here. So something which is not working like it should work. And this is okay. It's basically add missing users, users to the database. So it seems that the XResearch user is not yet in the database. This is strange because it should be in the database, but it could be that I just I think I gave a different name. So I have to quickly check if I perhaps screwed this if I screwed the username just up. If I'll open recent. So this is not important now, but I will just look this up. Yeah, this basically looks good. This is all username XResearch. So I'm not sure why we didn't upload the users. I used the KTV data. Let's see. So here we have somewhere users defined. Yeah, this looks all good. So basically this should have been uploaded. So I'm not completely sure where this error came. For now, what I will do is okay, open the issue for that. Users to database. Especially XResearch not found. So I will just open an issue for that. Okay, so issue and solve that by just removing this user for now from the curators. Let's just check if this was the issue. If not, then okay, I have to try something else, but okay, let's do that first. Yeah, okay. Okay, we always have to, sorry. We always have to check that we are on the right database. Yeah, this looks good. So just be trying to upload the study. Okay, this looks good. It solved the user. The SID is just complaining that a study with this ID already exists. This is because it already tried to upload it, but this is not, it's basically not bad because we only have one study, which is called Witte 1984, but it complains that we don't have a group which is called all. So that means we have now to start like curating actual groups. So it's basically, if you want to upload data, we need at least one group in which data was measured. Okay. For that, we will write now something in the here in this group. And what we want to write here is basically it's the information about our group. We have to figure out, okay, what is all the information which is in this publication for our group, and then figure out a way to write this down. Okay. Sorry, this here. Just that on the one side. Okay, this is now all a bit difficult to show. Normally you need a lot of monitors and see a lot of things, but okay, I will try to show how this normally works. Okay, so you have your publication, and then you have the study JSON. And so the first thing I normally do is now we want to encode these different fields. We want to start with the groups. is basically here this. We want to fill this out, and later on we will encode the interventions, and then we try also to encode the data. So for the groups, what I normally do, I just put I copy the data from the publication which is relevant for the groups. Okay, and this is basically sentences like this here. Pharmacokinetics and pharmacodynamics of the angiotensin converting enzyme inhibitor were investigated in 10 healthy normotensive male subjects. So this is important information because this says, okay, our group consisted of 10 subjects. They were all male. And they were normotensive, which is also important for our use case. And they were all healthy. So this is all information which we somehow have to write down, because this is important for the model. You can imagine, like, okay, if you would now have like 20 Thai subjects which were all hypertensive and had renal impairment, this is of course a totally different group, and we also have to simulate this totally different. So this is basically the information which is later on related to translated to, okay, we have to do different simulations with different parameters for these different groups, because none of these groups is comparable. Everybody has some renal failure or some heart failure, or it's females or it's males and so on. So this is all very, very different groups. So this is really why it's important to have this group information, or if information about individuals is given, why we need this individual information. Okay. Normally, you have a bit of half sentences sometimes in the title, sometimes in the summary, but normally you have an experimental design or a study group or so on. It's normally in the materials and methods, and there you have additional information. So I will also just copy this out. So this is the information that 10 healthy normotensive male volunteers, and now we get a bit more information: 34 to 47 years, weight 69 to 88 kilograms, all non-smokers who had not received drugs for at least 1 week took part in the study. Okay, this gives us a lot more information because we know they were not on medications, they were non-smokers, we know the years, we know the weight, or at least the weight range, and this gives us this is all important for the simulation. You can imagine if you build this physiological based model, of course we want to adapt it and then simulate a person which is as similar to the persons which were in this group for which the data was reported. So next information, this is basically, I will just copy that in. Not everything has to be encoded, but normally I'm putting everything in which is relevant for the group and is used to characterize the group. So here, from 2 days before the trial, day up to 48 hours after dosing, the subjects were maintained on the standardized meals and beverages with a constant sodium potassium content. Yeah, and this is probably important for the that you didn't have any changes in sodium and potassium during this phase, because this could of course change the blood pressure. And all subjects fasted overnight and then ingested a single oral dose of this ramipril at 7:30 with 150 milliliters mineral water, and then standard breakfast was consumed 2 hours after dosing. So this is basically everything which we know about the group. There's also a bit of information about the interventions in here. So some things we can directly copy down to the interventions. There we also have the descriptions. Okay, so we know that about the group, and there was also some information about the interventions, blood sampling. Let's see, somewhere there was here, there's information about the dosing. Here, especially after a single oral dose of 10 milligrams, this is ramipril. This is basically the doses. We know it was an oral dose. It was probably a single dose, and was 10 milligrams of the ramipril. So this is also information we get out of this. So this is basically, I would say, the high-level thing. You read the paper and you try to put information which is fitting to the different parts of your of the information. You try to copy it into the study JSON. Also, other things are important, like the assay method and so on. But okay, for now, this is basically what we have about our subjects. There's nothing more in here, so we will try to encode this now in the here in our group. Okay, we don't have any subgroups here. There's just a single group of 10 subjects, and for this 10 subjects, all the data was measured. So so we're pretty sure that okay, these time courses here, this is just the mean and SD of 10 subjects, because there's nowhere reported, okay, we did an analysis for 5 subjects and so on and so on. So this is pretty straightforward. We have one group and there are 10 subjects in here, and mean and SD data is reported for the subjects. Here also the same. So this is all we see also n equals 10. So this looks all yeah, pretty straightforward. Okay, so what we need basically our study, which is which is our study ID, and then we try to write down the information which we have. So the study name is basically it's called all. This is basically the highest group. This is a group of all subjects which were used in a clinical study. If you have subgroups, you give you will have less subjects than in the all group, and you would also write this down, but below here. Okay, but if this occurs, just ask, and I can we will provide information how to do this. What we know, group count is basically how many people were in this group. Parent is basically saying the relationship between parents. This is relevant if you have subgroups. Then you would encode the subgroup and say, okay, the parent group is, for instance, the all group, because the subgroup came out of a larger group. And this is often important to have the relationship between the different groups. And then you have to fill in the information, and this you basically do via the using the right measurement type, which is basically the information. So the information you have, and then you write down the values for your information. Okay, so the first information that we have, like, is, for instance, okay, this were all human subjects. So we know that all 10 people were humans. Yeah, and we can look up the available fields which we can use to encode information here via this very small button up here, which is obviously reachable via the XResearch Curation. And this gives you a bit of front end which allows you to filter for things which are allowed in the database and which you can put into these tables. So in our case, we want first to encode the species. So we see here there's a label. There's basically yeah, there's a measurement type which is species, and there's a bit of description. What does it mean? Species is a group of organisms and so on. Okay, and you have certain choices which you can use, and basically the thing which is here in fat in bold, you are allowed to write in the database. Okay, if you need additional information, you would just basically open an issue or write a short information and saying, hey, I can't find this information, which is important for my study, but it's not yet in the database. And then we would just add this additional fields. But often there is some way already to encode that. So yeah, the big challenge is to figure a bit out, okay, how do you encode the information you have? In our case, is a measurement type is species, and here are the allowed values. So an allowed value is Homo sapiens. So we would just write this in our data. You can also see basically a species is it's categorical data. So it's not, you don't have any values. You can't be a species of 1 or 2 or something, but this is categorical data, and so you would use the choice field. For other measurement types like blood pressure and so on, which are numerical data, you would then use like this mean and SD, min, max, and so on, these numerical fields to fill them in. So yeah, here this is categorical. So we only use the right choice, and the choice is Homo sapiens. So this would be the first information. We know we have a group of 10 people. We call this the all group, and these were all from Homo sapiens. Okay, let's quickly check if we can upload that now. Okay, this looks better. Okay, this is still complaining. Let's see what's going on. Perhaps I didn't save the file. Let's see, not sure. I hope this uploads now. No, a group with the name all is missing. Huh. Yeah, then information required. Okay, let's see what's going on. What I did wrong. Huh. Super strange. This should basically work. Ah, okay. Makes sense. Okay. Sorry. A lot of things is a bit complicated, and in the beginning you will have a lot of questions. Okay. The point is, okay, we defined the information in the table, but we haven't mapped this in the study JSON yet. This is basically what's here is basically we say like, okay, we're not uploading anything. But of course we have to say, okay, which groups do we want to upload? And here we basically say, okay, we want to upload the groups which were in this table here. So we have to provide once the mapping in here and to upload the data field. And this is basically, normally you just have this file and there's the mappings already in there, and then you just fill out the tables and you never have to care about the mappings. But because I removed all these mappings now, okay, we have to just recreate them. So I would just copy that from somewhere else. Let's see. Where do I have something? Basically, I just open another study JSON, and I would use here this group information, which is already in here, and just copy it in. Okay, and just yeah, basically for understanding what this is doing, it's mapping fields. Fields in the spreadsheet to fields in let's say in the database. So the name is mapping to the name, especially all these fields which we have in here. It's a name, group, count, parent. So these 3 fields which we have in here. And then we have additional characteristica. That's basically the measurement type, the choice, and then we have additional fields. Okay, we'll just put them to the side and just check that we have everything. Normally we have a mean. We can also have a median. So we'll just could have a median. Sometimes in some data sets, you could write median. We have a min and a max, and we have an SD, and sometimes you also have SE data. And you have units. Okay, so looks pretty good. And this is basically what this file here is defining once. It's mapping all these fields from this table spreadsheets to the fields in the database. But because our spreadsheets are not changing, you basically don't have to do this here. It's more like, okay, you would use this file where you already have these mappings, and then you're good. Okay, let's check if we can upload the study now. Okay. Okay, so pretty good. So more things happened. So what we see now, okay, it uploaded more things, but we get another error, which is basically saying count this field may not be null, and this basically means that our count cannot be 0. Okay, and this means like this count field we have to fill out, and this count is basically saying, okay, for how many of the subjects from this group is this information here in this measurement type relevant. So in this case, it's basically 10 of our 10 subjects are our group is at the size 10, and 10 of our subjects in this group are human. So it's basically just saying this measurement type is applying to the complete group. This makes more sense. Like sometimes you have a split. You have to, for instance, 5 are male, 5 are female, and here would be the group count. Okay, 5 are male, 5 are female, and this is the count would be smaller than the actual group count. Okay, let's see if this works. And then if this is working, yeah, there's some required information. So like we have to at least fill this out. So here a characteristic with the measurement type healthy is required on all groups. Okay, just to quickly show what healthy means. You can easily look this up. And healthy, yeah, if subject, yeah, it's healthy, and you have the different choices. Here you can say, okay, they were yes, they were no, or there was no information reported in the study if they were healthy or not healthy. So this is basically a high-level field. Like, so if you have renal impairment or heart failure, then healthy is basically no. If you have no disease and so on, and then it's reported as healthy, then they are healthy. So let's write this information. We knew that were 10 healthy male subjects, so we can basically encode this information. I will just copy some information from here and speed this up. So we know 10 subjects were healthy. So the choice is yes, they were healthy, and we know also they were male. So just to show this one, I would look this up. Yeah, sex as a subject, and we can select male, female. It's either mixed or it was not reported. In our case, all 10 subjects were male. So the sex of our 10 subjects was male. Okay, let's check if we can upload. And probably there are a few more required fields, but this looks good. And now it worked, it uploaded, and this looks pretty good. And now our data is basically in the database. And we can see this here. We can also see if we now reload our database. We basically uploaded the first data set. So we have one study and one group, but of course we didn't encode anything for outputs and so on. But our first, basically the first group information is in the database, and this data is now available under here. It's the WIT in 1984, and we have basically one group in our database. There's not much information. There's basically 10 subjects. They are all Homo sapiens. They are healthy and they are male. So all this data is now in the database. Pretty good, but we had like some more information in our groups, and that's where I normally copy this first out from the fields. So then I can just walk through all this information. So somehow we need, I will just copy this. We need somehow normotensive. Okay, I will just write this here for now. We have to figure out, okay, how we encode this. But then we have other things. It's like basically they were 34 to 47 years. So we will just write this here. In this case, we don't have any means and so on, but we have just a range. So they were between 34 to 47 years. This is now a numerical information, and for numerical information, we always need units. So this is here years. This is all for the group, because this is basically the range of the group we had, and I'm pretty sure this measurement type is called age. And here now we don't have a choice, but we have just the numerical data. We had this. There were 69 to 88 kilograms. We can encode this. This is probably weight or body weight. So yeah, normally you just have this the Curation tab open, and then you would just figure this out. Okay, weight status. Here we have something which is weight. This body weight of subject or animal. It's in kilograms. This looks pretty like what we want. Okay, this was weight. Yeah, so weight is correct. The weight was reported between 69 and 88 kilograms. Okay, we also had the information they are non-smokers. Okay, we have to encode this somehow, and did not receive drugs for at least 2 weeks. Okay. Okay. What else? Fasted overnight. This is also important. Fasted overnight. This is important. And there's breakfast and so on. This is not so okay. This is not so important. The fasting is often important, and basically everything which is characterizing the actual group. Okay, so let's figure out if we have something to encode the normotensive for the group. Okay, we don't have normotensive, so let's see. We have something like hypertension, perhaps. We have some hypertension. Okay, this is more like a disease. Normotensive, we don't have. Okay. Perhaps we have blood pressure. It's good also. Sometimes you have to figure out how to encode this. Yeah, we have blood pressure. This, or at least I saw something. Blood. That was it, pressure. Let's look for pressure. Yeah, here we have something. Okay, we have hypertension. Okay, this is mainly if we have the disease, there are hypertensions. And we have blood pressure diastolic. This is also not what we have. MAPS, blood pressure systolic. Here we have a general blood pressure. Okay, this gives us just the millimeter Hg. Then we have a blood pressure categorial. This looks pretty good. And this, yeah, and this is basically just telling us, okay, how was the category, how the blood pressure was measured. So this is basically here we have normal or elevated, and here we would use the blood pressure categorial as normal. So this is here we had to figure out a bit, okay, how is this encoded? Okay, and this was the I would say the biggest thing to figure it out. Okay, how is this reported? Okay, let's write this down. So we have the blood pressure. This is our normotensive. We would write this down as blood pressure. And here was a choice. This is normal blood pressure. Then we want to encode if they are smokers or non-smokers. So let's first just search for the thing. We don't have that. So let's look for smoking. So often it's helping to just use the reverse thing. So, okay, we have something abstinence smoking. Okay, here smoking, this looks good. Information on the smoking status, does subject or group smoke? And this is just a yes or no, and this looks pretty good. There's also smoking duration, smoking amount. We didn't have this. Okay, smoking looks pretty good. It's just smoking, and we still have to say smoking, no. And then we wrote this down. So this is just smoking. And categorial, so it's no, no. And this is also valid for all 10. We have the fasted overnight. Let's search for that. Here we have something overnight fast, subject to overnight fasted. Okay, that's good. So overnight fast is like what we want. We also have to see, okay, this is also just a choice. So yes or no or not reported, perfect. So we can just use this here, fasted overnight. And yes, they were, all 10 of them. And then the only thing missing is here, okay, they did not receive drugs. Okay, this is a bit more complicated. Here I know that this is medication. And there are different things. There's basically 2 fields. Medication, the subject did not take any medications. And this is pretty valid here because 2 weeks is pretty long for most medications. So we can just say medication no, but we can also encode really the duration. So abstinence medication, how long did they not take any medication? So we will use both fields as a combination here. because 2 weeks is pretty long. So we will we'll first use the medication field. Medication 10. Yeah, of course we need the group counts everywhere, the counts everywhere. So medication is no, and then we had the abstinence medication, and all 10 did not take any medication for 2 weeks. So it's two weeks. Okay, just filling out the remaining fields, and then our table looks already pretty good. Okay, and then we encoded most of the information. We didn't do the meals, but they are not so important. But otherwise, everything which was written in here is now in this groups field. Okay, and then we see certain things. Okay, blood pressure categorical does not exist. Count may not be null. So okay, somewhere we forgot a count, and this here, and somehow this here doesn't seem to exist. Okay, so probably we have a typo in there. Because most of the time, if we found it here in the database, then it exists. We just have to do. I could imagine that we have a typo somewhere. Let's figure this out. And try the re-upload. Okay, so yeah, there was a typo, and now we, if you look again at our database, we have. What's going on? Oh. We should have more data in there. Oh, something went wrong. Okay, let's just reload the. Just click here on the direct link. Here we see the data is in there. So, okay. Yeah, and we see now we have much more information for our group. Okay, this is Homo sapiens, healthy. They did not smoke. They did not take any medication. They were overnight fasted. This is our age and weight group, and they didn't take any medication for 14 days. And this is a pretty good information. And yeah, and later on, of course, we will have different groups. We will have the renal failure group, and they were not healthy and so on. But this is basically how we would encode all this information. Okay, this is the first table. Let's move on to the second table, which is basically the interventions. And here we have to describe, okay, what was done for the data which was measured. So we're mainly now interested in in describing what was done, like basically which group was, in the end, to describe this data, we have to say, okay, in which group was this measured? This is the all group. What intervention was given? This was the 10 milligrams ramipril. And then we have to say what was measured here. And what was measured was basically the concentration of the ramiprilat. And then we have to put the data in, which is the time points and the concentration mean and SD values. And the unit, of course, what it was here. So we want to fill this out, but for that we have to define the groups first. Or if this would be individual data, the individuals, and we have to define the intervention. So what was done here? And what was done here is basically that 10 milligrams of ramipril were given. So here, study column is always the name of the study. Now we have to give an intervention. Here I would just use the ID, which we give also in our model. So real is for ramipril. and I call this just real 10. And then it's a bit, we get a bit of information what was given here. We have to say when was this given? And normally if you have a single dose, this was just given at the time point 0. So it makes some more sense. Okay, to measure this curve at the time point 0, which was 7:30 in the morning, they gave the 10 milligram oral ramipril. So this is just that we need the time here. The time unit, this is just at the 0 point. We have to define the root. The root is oral. So I will just look up what the exact read ID is. So we have here like something. Now we have administration root. And here we see, okay, we have something here which is called oral, and always use the black bold thing as the key in the database. So, so it was orally, and then we have to fill out a bit more information. The substance basically we have to fill out. It's ramipril, and what was given, it's 10 milligrams. Okay. In addition, we have to define the application and the form. It's a bit more complicated. Okay, the form is basically okay. Let's see the application. I think we have different things. Let's see if this appears here. If we do application, yeah, you can basically see which fields are allowed for application, and application is basically saying, okay, how was this given? And for most of our studies, this is just there was just a single dose given at the time point 0. You could have also infusions or clamped infusions or multiple doses and so on, but most of the time this is just single dose. Here for us it was just a single dose which was given at the time point 0. Okay. I think this was single dose, and then we also have to figure out the form. Okay, this is basically the administration form here. And there can be different things: capsule, solution, or tablet are the main things. But as far as I remember, this was not reported. So probably we have to use not reported. No, it was okay. It was reported here. They said basically, okay, they gave a single oral dose of this HOE 498 at 7:30 with 150 milliliter non-aerated mineral water. Okay, it's still not given. It could be a solution. It could be a tablet. It could be a capsule. It doesn't seem there is any information in here. They're not saying anything, so we have to use not reported here. Like I said in one of the first lectures, it's always important what the application form is, because solutions are much faster absorbed than tablets and so on. But okay, we didn't have that. And then in the end, we need the measurement type. Okay, I have to quickly look up what we should write there. I'll just open another study. Yeah, measurement is dosing. Yeah, and this is basically you just have to write dosing here. Nothing. Yeah. And this is just saying, okay, this was intervention which was done. Okay, and this would be everything which we have to encode for the dosing. I would.
I have a question, if that's okay.
Yeah, of course. Can I ask? This is
in my paper, the substance was given in different types, like it was a solution in apple juice, in water, and it was in applesauce, and I'm not really sure if that counts as a solution.
Yeah, that's the same question. It's a solution, but it's of course not a water solution, but you would encode the TS solution. But in this case, you would also write this as a comment here.
Yeah,
this would be the important thing.
What the solution was. Okay.
Exactly. This is often important because this is more in the Like most of the time, it doesn't matter at all. If you
Yeah.
use apple juice or water, it's more like in the end, if you do the simulation and you see, oh, I see very strange differences between the different solution groups, which I can't explain with my model, then you would open this file. Basically, the first thing you do is you open this file here, and then
Yeah.
you would see the comments, and then you would be, okay, they weren't, this were different here. Perhaps this could explain why the data is not fitting to the model.
Okay.
This is more like why it's important. Like you try to do this as standardized as possible. But if things are not fitting in here, try always to write it as in the comments or note it somewhere, like or ask what you should do. I think this is the best. And then we can't write everything in the database, but we do basically the main things which could affect the pharmacokinetics or pharmacodynamics. Yeah. Yeah. Long story short, just use the dose here, use solution, and write in the comments what kind of apple or whatever it was. Yeah.
Okay, thanks.
Okay, that's basically it. Here for the interventions, but now of course we have to do again the mapping of the in our study JSON. We have to do the mapping between this table and the actual database. So meaning we need the like this basically this block of interventions, which is doing our mapping of the intervention fields. So I copy this here now in the interventions. Yeah. Yeah, perhaps also with this apple juice. That's why normally I'm doing this two level thing. Like in the first step, like I really just copy the large sentences which describe the stuff here in the overall descriptions of the intervention. And then if I have specific information for the intervention, I put it in the comments. This is normally what and then it's definitely somewhere written if something is strange. Yeah, and it's easy to find afterwards. Yeah. Okay. Yeah, so here we again do a mapping. We say in the tab interventions, all our information is here mapped. So we have substance, time, do we have the time end in here? No, I have to put it in. The time end is not important. This is more, this is only relevant for infusions, because sometimes it's saying, okay, we're doing an intravenous infusion of this medication for 30 minutes. And then of course, to be able to simulate that, you have to know, okay, it starts at time 0 and it ends at after 30 minutes. So for that, it's important. So I would just write an NA in here. It's not available or not important. Let's see, we have the value, let's see, value, unit, root, application form. Okay, that's all in here. So we did the mapping, and now we try again if we can upload that and see if we have then the interventions in there. Okay, something went wrong. Here's basically header key measurement does not exist in data, blah, blah, blah. Okay, so here I say measurement type is mapping to measurement. So because it's not how it is, because the measurement type is mapping to the measurement type column. It was just basically in this other file, the mappings were a bit different, but okay, I'm just adapting this now to this. This is actually okay. Now we see here we get this is also something which we will get sometimes. This is basically the object does not exist. So we said we want this was ramipril, but because nobody ever encoded anything with ramipril in the database, we also don't have ramipril in the database. So if you just look for it, we're not finding anything. Many other substances are in here, like it's caffeine, and so on, but ramipril is not yet in the database. And this is a point where you you basically have to write a message and say, okay, I need this additional fields in the databases, for instance, for substances or for this information and so on. Often this can be solved by, okay, you have to just encode it a bit differently. But here with a ramipril, it's really this information is missing from the database. And only if you write that, then we add this to the database. I will just show this here for the how this works, that you get a bit of feeling, okay, how this is in the backend. Obviously, we have like some tables where things are defined. And okay, this is strange. I already defined that. Yeah. So and I basically already started before to adding this. I just haven't uploaded it to the database. And this is what you normally have to encode a bit of information. Okay, what are your substances? What you need, you need a bit of annotations. And you need a bit of descriptions what this is. As far as I remember, we did the annotations already in the when we built the models. So we can just reuse the annotations. Basically, we looked this already up in the databases, so we can just reuse that for the definition in the database. And we would also use let's see, add the ramiprilat. This identifiers. And we would add a short description for that. I would just look this up quickly in the database. Ramipril. Okay, this is not a nice description. Normally I'm looking, it's basically the information which will later be available in the database. And I'm just looking for some nice description what this is. So this National Cancer Institute, this provides normally a nice summary which is relevant for us, yeah, and Rami is converted in the liver, ramiprilat, and so on. So this is secretion. Okay, so this is a really nice description which provides people with information. Okay, what's going on here? Okay, moment. So just quickly formatting this, and okay, this is. Sorry, this is definitely can be done easier, but okay, for now I'm just copying that here. Yeah, normally I can do this automatically, but just now to show that. Okay, this is basically the information we would normally put in here. Same for ramiprilat. I would, and of course, if I look this up, I can also add this this database cross-reference. It's more like, okay, if you already here's where you try to collect as much information as possible, which makes it in the end easy to find information in the database and to understand, okay, this is the same thing. Like for here, for instance, okay, an important thing which we have to do is like defining synonyms if there are any available. So we definitely have this this synonym here, the Höhe 498. It makes a lot of sense to just define this also in the synonyms here, because then it's available via the database if you look this up. So, and this helps us to avoid duplication of information. So if somebody would just say, okay, hey, I need the 498, he would easily find, this is ramipril, and ramipril is already in the database. Okay, same for ramiprilat. I want to look up a nice description for that. Okay, it looks all good. Like this description. Adding this here. This is basically how in the backend we would just define the information, and then you would in the end you don't care about all this here. You just would use the term ramipril or ramiprilat, but then we can map this to many different things and just unify the information. Okay. And there was also a NCAT identifier. Okay. I'm not sure if I have to go the prefix here or not. I don't think so. Okay. And then what we normally do is then just upload this to the database. So now I have to say, okay, to which data this. I'm basically just saying here to which database I want to upload it. And then what I'm doing first, I have to create the nodes to check that everything is valid. Okay, I'll do just some code formatting. Okay. And now I would just try to create all this information and see if there are any errors in what I defined. Well, this is querying also a lot of additional information now from our IDs, which we put in here. This looks pretty good. It looks like it can create everything. So while I'm at it, I will probably also add additional information which we need. So what is so ramipril, ramiprilat we definitely need. But we also need a lot is probably the ACE activity. It's basically to be able to encode such information. We definitely don't have this in the database. And later on, we will definitely need for other pharmacodynamic readouts. I think the map we already had in the database, but there were a lot of other this vessel pressure measurements and so on. This is definitely not in the database yet. Okay. Was more like the plasma ACE activity. But this is something I would add and just open an issue for that now that I don't forget it. I'm missing. Okay. And this would be basically also like a nice way for you. If you need information, you would just write, okay, in my study, blah, 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 Witte 1984, I need to somehow encode this this information. I don't know how, and so on. And then we can basically solve that and find a solution for that. Okay. I'm writing very nice reports here. This is just for me. Oh, that I don't forget it. Okay. Okay, let's go back and see what's going on. Okay, this was all successfully created, and now okay, we have to upload the nodes. Okay, unfortunately, this all takes pretty long, so I will just let this run in the background, and this is basically just uploading all the information and so on, and basically rewriting the database and doing lots of stuff like that. And in the end, we will just have the information we can upload these interventions with the ramipril. Okay, as long as this is working, we would start here with this figure 2. So now we want to really get this data out of here. And for that, we basically have to encode what was measured here. So we can basically try to fill out what we know. So the 1980, this is our study ID. We know this. We know this was not measured in individuals. This was just measured in a group. And this was measured here in our all group. There are 10 people in here. Okay, this is okay. This is a bit of duplicate information, but please fill out the counts. If possible, this makes it later on. This makes different things easier, but okay. But you don't have to fill it out, but it's nice if you fill this out. Then the intervention. Okay, what was given? We know this real 10 was given. This is our intervention name or intervention ID. And this basically just is a shortcut for writing all this information. So we know basically in this group with all the group information, the real 10 was given. And then something was measured. Okay, and what was measured is basically a concentration. and the concentration of a certain substance. And here we know this metabolite M1, it's the ramiprilat. So we know the concentration of ramiprilat was measured, and then we have to say, of course, where was it measured? It was here measured in the serum. We call this. We would write down the method with which it was measured. This was reported in the study. It was this. You normally find an assay or assay method, and it's here like it's basically a combined method. You have HPLC for the M1, and the urinary concentrations were measured with capillary chromatography. So this will be most likely be HPLC. Just to show how you would normally look this up, it's basically the same. You just look in the database and you see like, okay, there's a HPLC which you can use for the method field. So you can just write the HPLC here. Label I will explain in a second. And the rest is basically data, which is, okay, we have to get the data information out of here. So the units we can already write. We know the time units on this plot are in hours. And the Y units here in nanograms per milliliter. Basically, this is what we know. And now it's basically, we know, just copy that a few times. We now have to fill out the actual times, the actual means, and the actual SDs, and have to get this somehow from this plots. Now we're doing this especially by data digitalization from this plots. Okay, so normally like the 0 point, you don't really digitize because here it depends a bit on the study, but here you know, okay, this is really a 0, so you can just write the time 0. It was a measurement of 0, and there's basically no SD or no SE on this. So we're just using the SD field because there's SD data in here. Okay, quickly checking if this uploaded. No, still takes forever. Okay, and so now we have to try to get the data out of this plot. So let's see if this works here. So we will use a program for data digitalization. Let's see if I have I hope I have this here. Oh, no, of course I don't. Okay. Perhaps an important information is a lot of this, a lot of the information I'm giving now is also like written down in this Curation markdown here. So this is a really important file. There you can find a lot of information about the how things should look like, how you set up environments, and so on and so on. It also shows here, okay, how you would do this upload study and so on and so on. It shows a bit of this commands, and it explains, okay, how things should look like, how the files should be named. So there's a lot of information in here. It explains like this study JSON and so on. So a lot of information is here, and often if I don't know what's going on, I'm also looking this here. Like for instance, now I'm looking up the plot digitization. So it's more like, okay, you should use this plot digitizer. It's or at least for me, this was a nice tool which worked. If you find something better, please let me know. This is basically just a tool I download now. And we'll start and then load the figure in. Okay, what kind of file is this? Oh man, okay. So normally, and normally Google is your best friend for a lot of stuff. So I also have no clue how to do many things. I just have to quickly check what to do. Okay, so I have to do just a tar. Okay. Okay, and then I just go here in this file, and there we have a jar file, and this we can just execute, and we'll get a program which allows us to digitize things. So this is basically how this plot digitizer looks like. And now what we're doing is we're just opening our plot we want to digitize. So this is Witte figure 2. I want to start with that. Okay, you see that here? Okay, I think the most important thing is make this plot as big as possible. The smaller this plot is, the more difficult it is to click on that. This is just the thing. So here's the zoom. So just zoom in until until this looks, okay, this is a bit too big, but this looks pretty good. Okay, and then of course you have to define, okay, where are the axes? And normally, like, you would click on calibrate, and then just really define where are your zeros. And so you start basically with a x lower limit. This is basically your x min. This is 0. Okay, we always have to be careful with the axis. If the axis looks strange, this basically often you have log axis, or the axes are not really equidistant, but this looks, I would say, pretty okay. The 48 looks the same distance like the 24, I hope, at least. Sometimes this is really strange. If you, sometimes you're really unlucky and these are really bad axes, but it's more like then you know where the points were, or the points are reported in the study, and then you have to figure out, okay, what were your time points. But for now, we will say, okay, this was okay, this is of course not very nice. Okay, this is probably not the nicest example. We already see there are some problems here. This is basically the 72. And then we would use this was wrong. So I screwed up my calibration. Okay, let's see. Let's do it again. So I have to do 0. Use X calibration for Y axis. Use this point for, no, we don't want to use this point. Value for X axis. Okay, this is an important point, and we don't want to use it because you can see here's an offset, and this is really bad. So we want to really click on all the axis points. Okay, here this is our 72. Because now we can click 4 times, and so this is our 0. It's not a logarithmic axis, and then we have here our 22. Okay, top. And then we have calibrated everything. We just give a name for the x, and this is just our ramipril. Okay, and then you can start clicking on the points. Okay, I will do this 5 more minutes, and then or a few more minutes, and then I will be basically done here. So it's just basically clicking here as good as possible on this plot. Not very exciting, but okay. This is basically what you have to do. There are like some automatic things which try to get the points out, but often they're not working very nice. And especially they're not very, other tools I tried, they're not working very well with the error bars. So basically, I will just have it done. Then I get a table here, all the data. Just be careful to copy really everything. And then you put this just in here in the, okay, I will just put it in here somewhere. Okay, looks good. So our data points. We see here, like, this is basically the error you normally do. Like, you do a few % of errors in the digitalization. This, I would say, like, you wanted to click a 0, but okay, you have around 5% you're clicking wrong. But this is not too bad. Often you're better, but it depends a bit on how good you digitize. Okay, but this is our real 0, and then This are our data time points, and this are our mean values and stuff we don't need. And then we just need the SDs. Yeah, and you can basically see, like, if you look now at here, these time points and compare them with time points which were reported in the study. So you're getting here basically time points. So you normally can figure out, okay, what were the actual time points? But where is it? Oh, basically started 15, 30, 45, and so on. But this is clearly, let's say, certain things are matching here, but it's okay. I would say this is not matching very well. But it's at least for the large, like basically for the large parts, you can, yeah, you can figure out certain time points, and then you should correct them where possible. Yeah, for instance, you saw, oh, okay, this is all vanishing here. But you basically see, okay, they measured at 72. So that's what I meant here. You have a certain error here in the digitalization, but if you know the time points, then you should like basically fix this here. This is like one of the things you should do. So basically for all the stuff here, 32, this looks all pretty good. And also this is a good check for our digitalization. We have a 24, this 20 looks pretty good. And we have a 16. Okay, that's good. We have a 14 and 14. And then we already, okay, see this 12, we clicked really bad. We have a 10, 8, and you can normally do this for most of the time points if this is given in the study. But okay, we have a 4, a 3, and then it becomes, okay, this becomes really, I don't know, I wouldn't trust this too much. We have basically the, okay, 2 hours, 9, I don't know. Here, this should be 2.5, but it's not, but it's, I also didn't click too bad. So this is, yeah. Okay, let's see. We have the 3. It should be, oh, no, it should be the 2. This should be the 1.5. And then you, it's a bit unclear what is this lower data point. So we just leave them as is. Okay, that's a one thing. And now the second thing is we of course need the SDs. Okay, sorry, almost finished. But okay, the point is I have to do the SDs right now because you always have to use the same axis if you digitize the data in the error bars. Okay, and hopefully we get the same amount of points. Okay, we click again on digitize. Okay, this is still this here, and then we hope that this is working. So, okay, this you can see this should be this here. And that's the problem. If you forget one, then you basically have to do this again. This looks pretty good. Okay, and here it's pretty easy because you see all the error bars. But often you also, if you don't see it, then you just try to do your best. That's here also the thing. Like you just have to try to do this as good as possible. I think this is the point. And it's not it's unavoidable that there are certain errors, but this is still like much better than having no data. Okay. So and now the big hope is that this is just fitting here. If I put this in the SDs, I have to add here a new column, and that these are hopefully, man, crap. Okay, so normally this should be the same amount of points, but somehow I forgot something. But hey, I couldn't say which one I forgot, but so I luckily have the okay. I luckily have the time points also. So okay, so we have to just figure this out a bit. So this is a lot of this, I would say, data digitization, just trying to figure things out. So I would say this looks pretty good. So this is until 5, 4, 3 until the 2. So let's just check if we copy this in here. Basically, if this is fitting and we just forgot one in the beginning. Yeah, this looks good. This is our 2. And then we have the 1.6. Ah, yeah, okay. And it fits because we didn't do the 0. So, okay. Makes sense. So, okay, we didn't forget anything. We just didn't digitize the 0. Okay. But this is, of course, now not the SD, but what we did in reality is basically the mean plus minus the SD. And we have to calculate the actual SD from that. Okay, but this is pretty easy. We're just doing the, okay, here we know this NA, and this is just the absolute value between the mean, which is our N4, and minus our O4. We can just calculate that, make a quick, what's going on? What did I do here? Oh no, man, is this a minus? Oh man, okay. Yeah, but that's basically how data digitization is. Hey, man, really did I screw this up? Okay. Okay, the problem is here that this is a minus value here. Of course, the first one. So this will all not work. So I have to fix this here, but for the rest it works. Okay, and this is basically how you always should think a bit if you do things. So here this makes somehow sense that you have 15.27 SDs if you see that here. Okay, but here this value is not correct, and it's more like or is it correct? It's correct. Does it make sense? Okay, yeah, it makes sense. If the error bar is going under 0, then the error is bigger than the mean. Okay, okay, makes sense. Okay, perfect. And I would say this is basically how you do the data digitization. You remove that here. Okay, and put this here. Okay, so far so good. So what you now should really try to do until the next time is that you take basically get the data from the repository. Give me 1 second. Where's my? So I will. So this is. I need the right repository. So basically I changed a lot of things here. I will save everything. And you should now try to do the same thing for your study. As far as you get. And then ask questions if you have problems or if things are strange and so on. Yeah, but my hope would be that you do that you basically that you at least try to do the Excel file, do the groups, and try to do the interventions. That you create the screenshots, meaning creating these few screenshots, trying to create a first study JSON. And yeah, and a nice thing would be if you also get this this upload working. This is probably the biggest problem, but even if you can't upload it yet, you can still you could try to encode the information as good as possible here in this JSONs and try to fill out the information. And then we would help you with getting this upload to run. And then you get basically feedback from the scripts also. Okay, what should be changed and what should be updated. Okay. Yeah. I know there's a lot of information. Please just ask. The thing is, you just have to start with that, and then there will be issues, 100%. But you just have to ask and try to get as much information as possible from at least the groups and the interventions in this Excel spreadsheet. Okay, and then next time we would finish basically how you do basically the upload of this data and finish the table which we still have, and that's basically it. And then the tables are also very similar like that, and yeah. Okay, sorry for that it took a bit longer. The problem is if you start like with this digitalization, you really have to put in the table, and you normally should finish one table, and then if you stop in between, then often you just forget what was wrong and so on and so on. Also, like if things are really strange, what I do, just mark them with yellow and write some comments here. This helps you later also just to figure out, okay, where are things strange in the data? Yeah, this is also what I'm doing often. Okay, so far so good. Are there any questions until here? Okay, so yeah, just give it a try and see how far you get. And yeah, and we will please write us if you try to do the upload, then we can help you with setting this up, that it works on your side. Okay, otherwise have a nice evening, and yeah, see you next week.
Have a nice evening. Bye.
Bye.
Thank you. Bye.
Bye.